In 1999, we didn't have internet at home, and my dad was working at a hospital as a male nurse, and they had internet. So on the weekends, when he had a weekend shift, I went there and I was hanging out on the internet. And then there was this new website, eBay, and I registered, or I tried to register, and I had to fake my birth date because I was too young to actually register. So 3 years ago, I had to call eBay customer support to then tell, hey guys, I have a problem with my login, and then they asked me, of course, for my birth date. And I had to say, yeah, I don't know. Because back then I didn't know what I'd put in 1999. And she was like, but how did you do that? It's like, yeah, because I wanted to be part of that. And it was amazing in a small town to have the ability to buy almost anything on the planet online. So my name is Toby. I'm a data engineer at Ricardo, and my talk is called Taking Data from Somewhere and Put It Somewhere Else. And that sounds like a job description, and actually that's my job description. So I prepared a video, and because I know it doesn't work, I have it prepared in the background as well. So I'm going to show you something from that year, 1999. And I hope the audio works, otherwise I will tune it up, but don't worry, it's just 60 seconds.
The internet is revolutionizing business, from egghead.com to eBay, from E-Trade to Excite. The companies that know the internet best use Oracle for e-business. Do you?
So that was from 1999, and I don't know about you, but all of these 4 companies, I had to research 3 of them to know what they're actually doing and if they are still in business. Fun fact, one of them has been bought by Amazon. And it's up to you to find out which one, so you can Google that after the talk. What is this all about? So basically, I joined Ricardo 3 months ago, and my job was basically in the DI team then to think about the new architecture Ricardo wants to build. And there's a quote by the hacker Conway, which is actually from 1967. And I find it really interesting because it reflects the reality of today so well and was already formulated back then, that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. And if you think that in your brain, then you will understand that, of course, if you have a system that evolves over time, it was maybe a perfect copy of the communication structures back then, but now it's too complex because the organization has outgrown that. And it's completely natural that you from time to time have to rethink that. And so this is the current architecture, or was the current architecture of Ricardo in 3 months ago, actually. And you don't have to understand it. I just wanted to show you that it was quite complex and grown over time. And it was perfectly doing its job, but it was just, organically becoming too complex to maintain, and also took 6 hours to process a day of data. So that was an issue. And also, in contrast to that, in 2018, everybody at every conference was talking about serverless. And that means that, I just put these up on purpose because I just Googled serverless, and then I took pictures from Google image search without any knowledge about what they're doing, actually. The point is here that serverless means that you don't own your hardware anymore, you don't run your Kubernetes clusters yourself, you just write your function, you deploy it, and it's I see Rich's face, he's really annoyed by that, he's a system guy, sorry. And you run you don't deal with the hardware, you just you let it run for yourself, and that's it, right? So that's the contrast. So 1999, Oracle databases, we don't run Oracle databases, it's just, that RDBMSs are still a thing. And then functions in 2018, so where's the bridge here? Of course, at Ricardo, there was also a technological shift happening, and in 2017, they started to push everything towards microservices and implemented a Kafka message queue bus. And for us, it means that we have a monolithic database that we had to copy data from into our new system, which was a one-off copy and then a daily sync. but also all the teams are now fragmented and they are basically moving towards Kafka, and we need to actually keep track of them and run after them and ask, hey, where's your data now? Like, how can we access it now? But because we need it and we need to report things for business and finance. Yeah, and basically all this microservice approach is still, I mean, it's still new because most of the people do it for the first time to actually do something live with it. I mean, everybody played around with it, I think, by now, or most of the people, but really having something in production, yeah, can give surprises. So we had an architecture workshop in the DI team at Ricardo, and basically in these pictures you see Reinder, Dominic, Stan, and Lori is unfortunately not on the picture, but I am. She took the picture. And we came up with a new architecture, and this is basically what I want to present to you now. And an important point here is that there's another law from another computer scientist from 1959, which goes even more back, who said that an information retrieval system will tend not to be used whenever it is more painful and troublesome for a customer to have information than for him or her not to have it. That means that if your system is complex and not easy to use, people will find ways around that or just not use it at all and say like, yeah, maybe the information is available, but I can't be bothered. So this is our new architecture, or that what we came up with. And at first it looks super simple, but that's the way or the purpose it's meant to be. I actually left out all the technologies, but because there will be talks, or there are talks on this conference who talk about the technologies that glue these things together. Namely, there's a talk about Airflow, I think starting after this one, and I recommend that you go there and listen to it, because Airflow is also a scheduling system that we use to schedule all the jobs that take the files and process them and load them into BigQuery. But most importantly, we have the opinion that everything that we take should be consisted as a file first. Because, of course, everybody talks about streaming, and I really believe that streaming is something we should invest our time in and do in the future. But ultimately, when you have a company that is being migrated from monolith to microservices, and everybody is doing something new and building something, then you need to have a way to snapshot your things. So the first thing we wanted to do was basically make sure that we have everything in one place and then load it from there. Because that actually enables you to rewind your processes and make sure that you get the data back if something fails. And most importantly, we do SQL. So no stored procedures anymore. Before, as you saw, there was a Microsoft SQL Server database which heavily uses stored procedures. But of course, stored procedures are harder to maintain as simple and plain SQL statements. And what's coming after this, so the top of the pyramid basically, is everything for the future. But this is not the basis for this talk, because I'm a data engineer, so it will be about engineering. Of course, changing the system was not the only thing that we've done, and I think it was mentioned today a lot of times that it's not only the hardware or the technology, it's more like the people. And so we changed our processes and made sure that everybody in the team is able and understand Python, because we said, okay, we're going for Python as a language where we all can collaborate together. Everybody has this special language, maybe R, maybe C#, but for projects where everybody has to touch it, it will be one common language. And also the process of writing SQL queries and then actually reviewing them changed, because I think there's no good code formatter or linter for SQL where everybody agrees this is actually readable. So what we came up with was basically a process where we are linting the code ourselves when we write it, because usually when you write SQL code, that stays forever. Because if you have a feature that is being tracked and you have a SQL query that corresponds to the tracking of that feature, it will be live as long as the feature lives, because people want to know how is this feature performing. that is actually all about the migration, and I think most of you have played with maybe BigQuery or played with GCS and played with all these services, but what about the future? So what about the stuff that comes after BigQuery, or maybe, as I said, this pyramid top, and what comes after Kubernetes? So right now, of course, we deploy our services and our processing power on Kubernetes, but maybe in the future we won't, because there is now a way, as I said, to do functions as a service on Google, and there's Google Cloud Container Builder, and just to give you a bit of context, Google Cloud Container Builder is actually meant to build images, so Docker images, so to say, but there's one neat feature which allows it to execute any command in an image for you and then process something with it. So they mention it in their own documentation, but it's very hidden in the documentation. I think it's very down on some page. What this enables you to do is basically you can take any bash script or bash commands and glue them together in Ubuntu image and do things with files. For example, and this is what I want to show to you today, you could actually have a function that acts on an upload in a Google Cloud Storage bucket and then triggers an image in Ubuntu with a batch script that downloads this file, gzips this file, and uploads the file again and tags it as done. Of course, you can do anything else with the file, but this is for the demo basically our main focus. So with that, there will be a live demo, so I hope it will work. Otherwise, I have a video recording, but fingers crossed that this will work. So, Google Cloud Shell, can you see it? Yes, I see. Awesome. So, Google Cloud Shell is basically just a normal Linux running command environment. So, what I have here, just to show you, I have this function in Tamedia TX. And the function is called index.js, and there you can see it. So I'm sorry, it's in JavaScript. I was shocked as well, but then I sat down and learned JavaScript a bit, and actually Node.js is not that hard. And what you can see here basically is the important part. So the blue part there, these are the steps in Google Cloud Container Builder, and you can see that in the first step, I'm copying a file with gsutil. In the second step, I use Ubuntu to gzip that file. And in the third step, I copy that file back again. And that's the whole magic. In the top of the file, you can see that I have an if clause where I just say, OK, I don't want to gzip files that are already gzipped, because otherwise you will have a never-ending function that triggers itself all the time. And to deploy that function and to upload a file, this is what we are going to do now. So let's, all right, okay, so this doesn't work because of a problem, but it's not a problem because everything that I just said is of course true, because we have this. So the same what I just did, I'm doing again in this video. So basically, you see this index.js function. I'm going to skip this part because what I just said about the file is still true. And the next thing I'm going to do then is to deploy the function. And there I give a trigger, and the trigger resource will be the bucket name, and the trigger event will be the Google Cloud Storage object finalized. That means that after the object is finally uploaded completely, this thing will be triggered. That deploying takes 2 minutes, so in the next step, I was going back to the Vim editor again, which is the best editor, of course. And then I was talking about, I'm going to tell you that the build timeout here that I configured is 3,600 seconds in the bottom. And that's really important because you want to abort when there is something running too long, because otherwise you get billed by the second, or not even a second, you get billed by the 100th of a second. So it's very precise. You can see here now that I have a file.json with some key and some value in it, so very simple JSON file, and I'm going to copy that file now in the bucket. So the copy was successful, and now I'm going to call, or basically crawl the logs of the Google Cloud Functions engine to know what my function has done. it usually takes about 1 to 5 seconds that the function gets triggered. You can see here now that the function has been triggered, but the callback hasn't fired yet. And for people who are not familiar with Node.js, Node.js is an asynchronous framework basically, so you have this event loop that is constantly asking, oh, has something happened, has something happened? And then you have asynchronous functions in the back, and you can see here now that in the second time I called this, the build has been triggered. So I'm going to enter that URL and visit it, and there I can see, yes, my build, which is not an image build, but just something that I did, was successful. And in the first step, I downloaded the file. In the second step, I was gzipping it. And in the third step, I was basically uploading it again to Google Cloud Storage. So then I'm going to check my bucket, Tamedia TX 2018. And in the bucket, you can see now that there's a dumps folder of the uploaded file and the gzipped JSON file. So now I have basically my whole processing logic baked into a single function. And with that, I want to thank you for listening, because I'm 1 minute over time. And especially want to Marie-Gabriela at Ricardo, I want to thank her for providing me these slides, because these are the first sneak preview slides from Ricardo in a 16:9 format. Because I was... So if there are any questions, I'm sorry, I have only 50 minutes of time, but if you have any questions about this, or you want to have the code or something, I can share it with you, and you can just come by and we can have a talk. And with that, I'm going to leave you and wish you a great conference. And thanks to the organizers, it's really a pleasure to be here.